Today, we delve into the heart of one of the most pressing and ominous questions humanity has ever faced. Strap in, because we're about to explore the mind-boggling scenario of a sun explosion in 2023. Can we survive this cosmic catastrophe? Let's find out together. When stars die, they usually undergo a process that is famously known as a supernova. These destructive phenomena are some of the most cataclysmic and also some of the deadliest events in the known universe. Astronomers using their advanced telescopes have already photographed the closing seconds of a huge red supergiant star before it erupted. For the first time, we now know more about supernovas than ever before. Let's see what would happen if our own sun went supernova. Join us in this video as we explore what the ultimate demise of our beloved sun might mean for not only those of us on Earth, but also the rest of the solar system. According to calculations, one solar mass, or the mass of our sun, is around 330,000 times the mass of the Earth, so it isn't depicted that our average star could actually go supernova at all, but if it did, then it would really be shattering every law of physics that we so far know of. Our sun's climax would be more akin to a balloon slowly losing air than a spectacular explosion. Very boring, but that won't excuse the fact that it would still be pretty destructive for those present on Earth or Mars. Once the giant at the center of our solar system becomes a cooler but still scorching red supergiant, it will devour everything that's present inside. Its radius, Mercury, Venus and the Earth, the Sun, will eventually lose much of its energy and zeal for death and destruction as it deflates repeatedly. It will go from being crimson red in color to completely white. Not surprising, this new form attained by a dying star is called a white dwarf. That's what the Sun's demise would really mean for our solar system. A place that was once teeming with life would be left completely dead. Although it looks terrifying, our Sun isn't quite expected to kick the bucket that way. But let's hypothetically imagine if our Sun really did go supernova to start the beginning of the end. How would that exactly unfold, and what would it truly mean for us? Typically, when supernova occur, they cause enormous destructive explosions that discharge tons of stardust into space, giving birth to even more planets in celestial bodies. The unit of measure of this type of stupendous energy is Fo, meaning 10 followed by 51 zeros. During the sun's lifetime, it will emit approximately 1.2 watts of energy. In a nutshell, when stars go out, they do so in spectacular fashion, announcing their demise as loudly and brightly as possible. In terms of raw power, a supernova is just about one of the most devastating natural phenomena in the known universe. The potential supernova of the sun would likely result in a similar extinction-level disaster in a somewhat tragic and poetic sense. The energy that the sun would release if this supernova would be roughly equal to what it generates over the course of its complete life. Now obviously, when this much energy is released, it results in some inescapable and incomprehensible amounts of radiation, and what this radiation entails for us is a possibility that we could simply never be prepared for. At point in our hypothetical story, we must enter a powerful little villain called a neutrino. Obviously it isn't actually a villain, but you might just believe it is one by the time we're done explaining. Neutrinos are unusually erratic particles. Though their mass isn't completely known yet, it is known that they do have some mass, and that mass is tiny. We're talking absolutely minuscule. It's tiny even by tiny standards, some 4.26 million times smaller than the next smallest thing in existence. The electron neutrinos have no electrical charge, so these weird particles barely interact with anything. Their interactions, if any, happen because of their nuclear charge are so infrequent that the chance of the neutrino colliding with an atom is 1 in 6.4 billion. Yes, they are genuinely that tiny, but don't let their stature fool you into thinking they're unimportant. When a star goes supernova, it releases an incomputable amount of these extremely fast neutrinos. Their speed is comparable to that of light, and because they're so small and have passed through everything, you can bet your bunker that you won't survive even if it's inside its very own bunker. Neutrinos can enter pretty much anything you could think of. When the sun explodes, we won't even see it until 8 minutes later. That's because this is how long the light from its explosion would take to reach us, but it will likely trigger the supernova early warning system, also known as snooze, a group of neutrino detectors that astronomers use to get an early warning when a supernova occurs. But even with that warning, there would be nothing to do. Every living organism and object on Earth would absorb around 21 sieverts of radiation. That's enough to kill a man 10 times out of 10. When these neutrinos get to us, we'll not only get sick within seconds, but we'll also be fast-tracked to a very painful death by way of extreme nausea, diarrhea, fatigue, fluid loss, cardiac problems, and neurological complications, just to name a few, and that's assuming that the sheer heat and energy from the sun exploding hasn't yet gotten us in a few seconds. This happens. The gist of the 8-minute journey is that we'd all die pretty damn quickly, but if you're terrified by this 8-minute delay, wait for the worst. The moment the heat wave hits the Earth, the sun-facing side of the Earth literally gets boiled away within seconds. This heat is going to be so intense that scientists believe it would raise the temperature of the non-sun-facing side to 15 times the temperature of the very sun. Our perfectly balanced cosmic machine would become unstable, causing planets to bump into one another, and without the sun's mass to keep us in orbit, Earth would likely start floating off into space. All that would remain would be a dense core and hot gas called a nebula. A supernova is a long-lasting event that will illuminate the sky for weeks, even during the day. The remnants of this stellar core, which are left at the supernova. An explosion will follow one of two paths: a neutron star or a black hole. In the case of our sun, only a spinning neutron star will be left as evidence. You've probably heard of this term before, but what exactly is it? Neutron stars are city-sized stellar objects with a mass so dense that a single teaspoon would weigh 1 billion tons. Gravity on a neutron star is 2 billion times stronger than gravity on Earth. In fact, it's strong enough to significantly blend radiation from the star in a process known as gravitational lensing, allowing astronomers to see some of the back sides of the star. Although they are small objects compared to the cosmic universe, they pack quite a punch. Neutron stars can spin incredibly fast on their axes. How fast neutron stars can spin as fast as 43,000 times per minute, but don't worry too much about it. We probably won't even be around when that. However, the same can't be said for Betelgeuse, a neighboring red supergiant located 600 light-years away from Earth by the name of Betelgeuse, which has been exhibiting unusual signs of its impending death for a little while now. Recent studies around the fading supergiant and other observations made about the stars in our galaxy have established that before a star goes supernova, there are very distinct changes that it goes through, similar to something we've already outlined earlier in the video. Betelgeuse is predicted to die in the next 100,000 years in the most spectacular way ever witnessed in the universe, and though our understanding of space should be a lot more advanced by then, assuming our species survives that long, it could be the first observable supernova in our galaxy since the 1700s. Supernovas are something that is still shrouded in some mysteries to which science has no answer, and the same can be said for the rest of the universe. If you enjoyed this video, don't forget to give it a thumbs up, share it with your friends, and leave your thoughts in the comments below. Your engagement fuels our passion for unraveling the mysteries of the universe.